Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Migratory aptitude in 1-2 shifts, such as in Pinacol rearrangement, Baeyer-Villiger oxidation, or Wolff rearrangement, depends on the ability of the migrating group to stabilize the partial positive charge at the migration terminus through electron donation. For aryl groups, electron-donating substituents increase migratory aptitude and electron-withdrawing substituents decrease it. Moving on to the next step. Identify the electronic nature of each substituent on the para-substituted aryl groups. A. Para-OMe, methoxy-strong electron-donating group, EDG, by resonance greatly increases electron density on ring highest migratory aptitude. D. Para-Me, methyl-weak electron-donating group, EDG, by hyperconjugation induction moderately increases electron density second highest. B. Unsubstituted phenyl, no substituent baseline migratory aptitude third. C. Para-Cl, chloro-electron withdrawing group, EWG, by induction, net EWG despite lone pair donation, decreases electron density lowest migratory aptitude. Moving on to the next step. Rank in decreasing order of migratory aptitude. 4-MeO C6H4, A, 4-Me C6H4, D, C6H5, B, 4-Cl C6H4, C. This gives ADBC. And for the final step. Option B states ADBC, this matches exactly. Why other options fail? Option A, ACBD, places Cl above unsubstituted phenyl and methyl, which is incorrect since Cl is EWG. Option C, ADCB, places Cl above unsubstituted phenyl, incorrect. Option D, BCAB, nonsensical and places EWG-Cl above EDG-OMe. Therefore, the correct answer is B. Therefore, the correct answer is option B.